Okay, so this is for the 8th grade science class, but the kids that are in just regular 7th grade, feel free to watch it too. Okay, so I'm gonna start with the salt, atomic model of salt. I'm going to use I'm gonna make I'm gonna make it out of marshmallows and toothpicks. I have mini marshmallows too. So the mini marshmallows are gonna represent the sodium atom, and the big marshmallows are going to represent the chlorine atom in salt, because those are the two elements in salt to make that compound. So looking at this picture, I'm going to show you guys another picture when I edit my video, but this picture is a cube, right? So we're not going to make the whole cube, we're going to make a portion of the cube. We're only using 8 marshmallows, but we have to use 12 sticks. So I'm going to show you how we're going to do it with the toothpicks. And the toothpicks are the bonds. The toothpicks are going to hold the marshmallows together. So there is a pattern in the model. So they alternate. So it's sodium, chlorine, sodium, chlorine. Oh my gosh, I can't talk. Okay, so but they alternate. So the atoms of the elements alternate as salt forms when it becomes an atom. These marshmallows are stuck together, I think because I left them in my car. And they taste a little strange, even though I ate a whole bunch of them in class today. Okay, so I'm gonna use green ones. So this is one of those experiments that I tell you guys you can't eat your experiment. As long as your hands were clean and the items that you're using were clean, you can eat this experiment when you're done with it. But like I said, everything needed to be clean first. So to make this, using the 4 small marshmallows, these are going to be our sodium, and these 4 are going to be the chlorine atoms. So I'm going to stick the toothpick in the marshmallow, and then I have to, because it alternates, and I have to make it into a square because it's the shape of a cube. So I have to alternate it going like this. I'm gonna put it down on my plate because it's gonna be easier. The directions on the paper say to use a piece of paper. I think it's easier and better to use a plate. Okay, so this is just part of it, but we still have 2 more marshmallows. So we have to put these 2 connected together. The big marshmallow does not go on top of the big marshmallows, so we don't have 2 chlorine atoms on top of each other. So it's going to be chlorine and sodium, and then this one's going to be sodium and then chlorine. So this one is going to go, these might fall, so actually what I'm going to do is I'm going to make another one like this first before I put it all together. Even though I did it a little differently in class, it did stay together. It was definitely better than the model that I was trying to do to show other shapes of atomic atoms. Okay, so we're gonna stick these because this has to go on top of this. Okay, and it has to go on top this way because you have to have the sodium and then the chlorine. Apparently the coffee that I drank this afternoon is not helping with my speech. Okay, so this is our atomic model of salt, but it shows a bigger model on the picture. So the biggest difference in our model and the model in the picture is that the model in the picture is just, it's on a bigger scale. So this is like a section of the model that is in the picture. Just want to make sure. Okay, the last thing that I did want to go over with you guys is the bonds. So the toothpick is the bond. So, but the thing is that salt is both it's strong and it's brittle, which that sounds totally crazy, right? Like, how can it be strong and brittle? Because brittle means weak, like it can easily break. So what I meant by that, so the example in the paper said, oh, try to break the toothpick. I mean, I can easily break the toothpick, but if I take the toothpick and I like hit it with the hammer, it will crack with the hammer. So my example in class was, if I go like this and I just messed that one up. But if I go like this and I push on it, it's not gonna break. But if I take my cup and I slam my cup on it, it's going to break. So I'm not gonna destroy my beautiful model. Here is my salt model. Okay, and if you guys saw my little critters, these are my little turtles. Have nothing to do with what I'm teaching you right now, but they are eating some fruits and veggies and hanging out in the sun. This is not their normal habitat, just hanging out in the heat. All right, so I'm gonna now, that was it. That's it for this. Bye. Okay, so this demonstration is going to be the atomic model of water. So water is made up of oxygen and hydrogen. So it's H2O. So H2 means there's 2 hydrogen atoms, and O is just 1 oxygen atom. So the big marshmallow is the oxygen, and the 2 little yellow marshmallows are going to be the hydrogen. I know you guys are probably looking at my marshmallows and thinking, oh my gosh, that's so cool, they're colorful. They're actually kind of gross. So I don't suggest, they are not a suggested item that you should try. Okay, so to make our water molecule, we are going to use 1 big marshmallow and 2 little marshmallows. The big marshmallow symbolizes the oxygen atom, and the little yellow marshmallows are going to symbolize the hydrogen atoms. So the atomic symbol for water is H2O. H stands for hydrogen, 2 stands for 2 atoms, that's why we have 2. And then O is for oxygen, but there's no number after it, so it's only 1 oxygen atom. So we're gonna put them together. The picture that I have, I'll provide another picture in the video when I create it. But the picture of the picture of the water molecules they're like kind of like all over the place, and they're like kind of like floating around because water moves, right? Water it's not solid, there's movement in the water. So like gas, the states of matter, gas is like super fast, it's always moving around, it's like bouncing off the walls, jumping everywhere, and like water slows down a little bit, and then like solid is just kind of like still, and it doesn't really move as much. So it wanted you to like kind of see, so like some of the molecules are like facing different ways, and that's okay, it's still the same molecule in the picture. It doesn't matter that it's facing different ways. So this one's gonna definitely be different than the salt, because the salt was a big cube that we had all those like pieces put together, but water is consisted of a whole bunch of these little molecules that kind of look like a weird head with 2 arms, I guess. So this is one. So in this assignment, you are going to make 4 of them. So you just stick the 2 toothpicks in and connect them together. Just like that. And I don't know why I have an extra toothpick. Stick this in. It looks like a head with antennas, like a bug. Okay, so now I have my 4 water molecules. So this water molecule is water no matter what state it is, whether it's liquid water, whether it's steam from boiling water, or it becomes solid from ice. So it's always water. So This one actually made more sense when it said, okay, take 2 sheets of paper and here, this is what we're gonna do with the 2 sheets of paper. So I'm gonna show you what it, so it wants you to take the 4 molecules and put them together. Like you just kind of like spread them out on the paper, but you see how like they're close together? This kind of like shows that they're water. If they were, I guess even more tightly close, well, no, not necessarily tightly. Yeah, if they were tightly close together, that would be more like if it was solid, like an ice cube. But if I have another piece of paper and they're connected together like this and they're more spread out, that would be more like they're gas because they're bouncing around everywhere. So that was it for our water molecules. I actually went over just about all the questions that are in the lab sheet in Admentum, so doing it on Friday should be super easy with our little alien friends. Bye guys!